Now, our next speaker is Gonçalo Silva from Doist. He's a former Rails contributor, and he's going to talk about a language that Google created. Please,
Hi everyone. Off. On or off? Okay. It's funny, I don't notice it. So as I said, welcome. I'm glad to be here to do pretty much this is kind of in the middle. Okay. So as I was saying, I'm really glad to be here. This is pretty much one of my favorite activities for warm Saturdays, being inside a dorm with AC, talking about tech. So I'm going to talk about material design in practice. And to do that, first I'm going to introduce myself. So as it has been said, my name is Gonçalo. I lead the Android team at Doist, and where I also do product design. Doist is a very particular company in the sense that we are over 40 people collaborating in 5 different continents on productivity software. One of these products is Todoist. It's probably our best known product. It's used by millions of people to manage hundreds of millions of tasks. You can think of it as a supercharged to-do list. Obviously, we are present in Android. After all, it's the most popular mobile operating system, taking around 80% of smartphone share around the world. And last year, Google kind of revolutionized the design language of Android with the introduction of material design. Now, material design is bold, it's graphic, it's intentional, it's based on the principles of paper and ink. It's an environment in 3D space, I think. Yeah, 3D space. With its own physical properties, transformations, and limitations. You can think of it, as I said before, regarding the paper and ink, like elastic pieces of paper that move around the interface. There's also a really strong emphasis on meaningful motion. So, meaningful motion is used to guide the user's attention and delight him. And finally, a bunch of details, like morphing icons between states instead of jumping directly. So, material design is now about 1 year old. It was introduced at last year's Google I/O. And a lot of companies, a lot of teams, and a lot of indie developers have picked up on it. The fact that Google built such complete design guidelines has in fact helped the Android ecosystem strive, because as you know, there are not a lot of designers in Android. So when a developer starts making its own app, actually if he follows the guidelines correctly, he will land a pretty good app. So users' feedback has been really good. Material design has been critically acclaimed from renowned designers, and 1 year later, there's pretty much a rich ecosystem of material design apps. So it leads to delighted users, it leads to inspired designers, and it leads to a lot of panic from developers. So at Todoist, we took up this challenge of bringing material design to Todoist, and with just a few changes of grid and color, we have amazing results. But material design is much more than just grid and color. It's elevation, transformations, motion. So Android Lollipop, which was out last year as well, together with material design, brought over 5,000 new APIs, some of which help you build material design apps. But this is a big problem. I mean, progress in Android is really slow. Lollipop is only over 10% right now, 1 year after its inception. So when you want to bring material design to all of your users, a significant percentage of your users, like we want at Doist, we need more stuff. So Google, about a month ago, released a library. It's the Android Design Support Library. which brings a bunch of things from material design to your apps, to old Android versions as well. So it brings the floating action button, the button that represents the main action in your app, be it write a new email, or send the email, or add a new task. This is the primary action. The Android Design Support Library also has snack bars. So snack bars are little pieces of information that pop up on screen that can have an optional action and that you can swipe out of the screen. It brought something which is called tab layout, which lets you use material tabs in all of these Android versions. And a few other things. This is kind of a big one, coordinator layout and app bar layout, because it lets you build collapsing and disappearing toolbars, which is a very common pattern in Android. When you mix all of these elements together from the Android Design Support Library, you can achieve pretty good results like this, and it lays out a nice foundation for all the rest that you must build. So a lot of the things that you need to bring material design are actually missing. They are not in the Android framework before Lollipop. They are not in the Android Support Design Library. So at Doist, we basically got our hands dirty. And now I'm going to focus on 3 things which I consider to be some of the dirtiest we have done in terms of code, obviously, but to achieve a marvelous experience, the marvelous experience that material design sells. So the first one is about loading images. Now, the contrast is not that good. I asked them to turn down the lights, especially because I look better on camera when there's not a lot of light. But this is really not important. The thing is, in material design, when you want to put an image on an interface, you don't fade it in. No. You need to go overboard. You need to combine changes of opacity, exposure, and saturation during different durations and starting at different intervals. This provides a really nice effect when... Oh, that's why it didn't work. OK. This provides a nice effect when you are fading in an image from an opaque background or even cross-fading an image with another one. Now, image view, this is Android's image class. It can have a method for controlling the opacity directly, the exposure directly, or the saturation directly, correct? Well, not really. You can only control the opacity directly on an image view. But actually, you have something better, which is color matrix. Color matrix, the math is boring, but it pretty much gives you full control over how the color and the alpha components of each pixel in your image is drawn. So this is a lot of code. It doesn't really matter what it's doing. It's basically implementing the same chart you saw before with all the rules. And you just create this color matrix, which in each animation frame, you adjust for that specific animation step. You set it on the image view, and then you have that nice little effect. But you're going to face another limitation. We're talking about animation code. So this is code that is executed at least once every 16 milliseconds. And the setColorMatrix method is hidden. So you can't really use it. It's not in the public API. But this is bad, because if you need to create a new color matrix on every animation frame, you're going to put pressure on the garbage collector, and you are probably going to trigger it. Thank you. The problem with the garbage collector and animations is that when the garbage collector kicks in and freezes your interface and you miss a frame or two, well, the whole experience is ruined. The animation is ruined. The paradigm no longer works. So what you can do is actually access the setColorMatrix method via reflection and only create a new color matrix if you absolutely need to. The second trick, dirty trick, I want to talk about today is related to tint. And this is by far my favorite in Todoist. So material design brought something over, which is the material beam. And the material beam is pretty cool. You can define a set of system colors. You define these colors in one place of your app. And the system will pick them up and use them in various places. So for instance, if you specify a primary color, it will probably be used as the toolbar color, the top bar. If you specify an accent color, it will probably be used as the floating action button color. And you don't need to do any of this. You don't need to add, for instance, a round pink circle to your app. You can just specify the color, and it works automatically. So we use this extensively in Todoist. And we go even further because we have themes. We let users personalize their experience to their liking or their mood. And we don't duplicate all of these resources for each theme. That's really not scalable. So basically what we do is we just use these properties. We have these really small files with 5 or 6 color declarations that we switch at runtime, and bam, the app looks completely different. So this doesn't work before a lollipop. There's no tint. So once again, we had to build something. And this is how Android Material was born. So Android Material is a compatibility library that we've built that it chips in where the support library doesn't work. So actually, the design support library, sorry, AppCompat, has added tint support a few weeks ago, but it's actually not very thorough as it is in Android Material. So how does this tint work? Well, all you need to do is replace the system class usage in your application with the material version of each class. If you use drawables directly in Java, you can just wrap a call to material resources, and it will be tinted appropriately. Now, what's not very clean about this is the way it works. These 4 lines of code do all the magic behind the scenes, and it's pretty crazy. So in Java, the first thing you need to do in your constructor is call the super constructor. Now, the Android system, when you specify your UI, how you want it to look, its attributes, the first thing it does is reading these attributes. But there was no tint support before Lollipop. So the very first thing we do is demify your context. Now, this is an attribute that became available for views in Android Lollipop, which is you specify a theme for your view. And it didn't exist for views before. So we basically read it for you, and we wrap your context in a context theme wrapper, which means we fake your context, we attach your context to the theme you want to use. The second thing we do is give Android, the framework, a list of attributes that it's not really complete. We have removed some of the attributes using reflection to kind of not let it screw up. So if you have a drawable that it's white, it's an alpha mask, and you put tint on it and say, okay, I want this to be red. Actually, you need to read it and apply the red color so that now you have a red line instead of a white line. So we hide these attributes and tell Android that, this is all that you have specified. It's not. So we restore these attributes right after that, and then we initialize them correctly, as if you were using Android Lollipop all the time. The final thing, the third dirty thing I want to talk about, whoops, it's related with elevation. So this is a huge thing as well in material design. Elevation is a way to design interfaces that Google has been pushing forward with material design, where you don't think the interface is the same way as before. You think about the interfaces as if they lived on a 3D space. So the views are layered on these panes, and they have a certain elevation. And since this 3D world has light sources, it has an ambient light and a light near the top center of the screen, it casts shadows on views below it. Another interesting thing about elevation is that since there is a specific light source at the top center of the screen, the view position on the screen changes the shadow it casts below. So this is a huge thing in material design, and this is something that works in Lollipop and above, that people have multiple times actually requested Google to bring kind of support for this for older versions via a compatibility library or a support library, and that Google said multiple times that it's just not feasible. So we did it. And we added this to Android Material as well. So in this interface, there are 6 views. They are all elevated at different elevations. They have different shapes, and half of these shadows are drawn by the system, and the other half are drawn by us. Now, I know this might seem really picky because, I mean, it's just a shadow. You can just add a shadow around your thing and be done with it. But when you are, for instance, with your finger on a view, the view has a lot of elevation, and you move your finger on screen, you will actually see the shadow changing as you move the view. And this is really important to keep the material design paradigm going. So to use this in your apps, since this is just a library, you actually need to have a custom view. You can extend any widget on the Android system. For instance, you can extend a button and create your elevated button. And you need to create an elevation delegate on pre-Lollipop devices and only proxy two calls to it, the unattached to window call and the undetached to window call. As the names imply, this is called by the framework whenever your view is attached to the window to display or removed from it. So this workflow involves three things. The first one is elevation delegate, which I just showed you. This is like the main entry point to the elevation logic that you can use in Android material. So, okay, pointer. So this is exactly the same view, not elevated, elevated, and here's the shadow. Now, on Lollipop, I don't really know how this works, but it's great. It's like the shadow, it's not even there. It's not like part of the layout. But before Lollipop, everything you draw on screen counts as part of the layout. So elevation delegate, what it does is it adds something we call the elevation wrapper drawable around your view's background so that it draws the shadow around it. The problem with this is that if you add a larger background, if you add a wrapping background, you need to increase the size of the view. Otherwise, it will just compress and be smaller than it should be. And this is not something you want. But by adding padding, you make the view larger. So when you are doing stuff like displaying things side by side, this will change the layout in ways that you don't want to. You want this to work as it works in Lollipop. So we use negative margins to effectively draw a shadow outside of the view's collision box. So I quickly mentioned the elevation wrapper drawable. So this drawable is really simple. You give it your original background. It calculates the shadow length in each direction because, as I said, it depends on your view's position on screen, and it draws the shadow. However, it does not prepare the shadow for drawing. What does prepare the shadow for drawing is something we call elevation update runnable. And the reason for this is, and this is probably why Google said it was not feasible, preparing a shadow, especially if there are round corners, is a really expensive operation. It can take up to 5 milliseconds. And when you are drawing UI code and you have 16 milliseconds to be done with everything you must do, 5 milliseconds is just too much. You cannot rely on this to make like animations, for instance, because you're going to miss frames. And as I said before, animations are great until you drop a frame. After that, you might as well not have one. So what we do is actually that on the very first draw, when the user interface is loading, we prepare this shadow in the UI thread. So yeah, if the user waits 5 more milliseconds for the app to open, it's not that bad. But after that, every time we need to update the shadow because its position on screen has changed, we do this in the background. Another thing I want to talk about very quickly is how we draw this shadow. So the sides, they are pretty trivial. It's just, I mean, it's a rectangle with a gradient. That's it. Now the corners are not trivial at all. Like, it actually looks pretty good. Thank you. But it's not that good. This is a zoomed in image of a corner. And the major problem is that when you have like these rounded corners, sometimes like they start with a length and then they end with a much different length, so you need to make this size gradient. They can have different opacities at start and end as well. So there are many ways of doing this. None of them are trivial. And the way we did it, you can see here, but later I will like make the slides available, and it's pretty noticeable on a better screen. We basically pick the circle and we slice it up like a pizza. And then we draw each slice of pizza kind of like with an opaque, a linear gradient. So like linear gradient, linear gradient, linear gradient. But when you are zoomed out, like at the real size, you cannot see this. You can only notice this when you zoom it in like this. So together with the previous compatibility and support libraries from Google and the Android design support library, which is pretty important, and all of the things we have chipped in, they are more than what I showed here. What I showed here is just dirty because it either involves reflection or messing with the framework code. And this is something that we shouldn't really do. But sometimes to bring these gorgeous experiences to your users, especially if you're targeting like the vast majority of Android users, you might need to do stuff like this. So in Todoist, we have reached a pretty good result. All of these interfaces are dynamic. They are all rendered in older Android versions. There is no lollipop here. And we've been getting pretty good feedback from our users. We are currently in beta. We will be releasing very soon. So if you want to check out how these compatibility resources actually work on pre-lollipop on your devices, you can. You can just hit up the link up there. I'm not sure if you can see it. If not, just come talk to me later. And these are some of the libraries that we found to be really important to bring material design to pre-lollipop and lollipop as well devices. So besides the usual suspects of the support v4 and the AppCompat v7, the new design library, Android Material Recycler View extensions is another thing we have built to help us bring Recycler View to a whole new level. So it gives drag and drop to your lists, sticky headers, all of that. And it makes it really easy to use. And Heavy Player is actually a bunch of legacy code, but there's a few useful things in there. Thank you very much for your patience. Maybe you were expecting a more heavy code talk, but it doesn't make much sense to talk about material design without giving the context and why it's really important that you kind of bring it to your apps and to your users. Thank you.
So, thank you.
I look bad again.
I look better. So, now, does anyone have any question for Gonçalo? No? Wait a second. With the mic, it's easier.
Okay, it's not directly related to Android, but what do you think of implementing the material design in websites? Do you think it's feasible from your experience, or do you think because it's also for desktops, big desktops, what do you think?
That's actually something I planned to say during the presentation and forgot. We are right now seeing a lot of material design in Android, some material design on the web, and actually even some material design in iOS. Mostly Google's fault, but I personally think material design works really well across most mediums. So I don't think Google sells it as a system-wide design philosophy, as a system-wide design system that's not tied to Android or the web. And I agree with them, but I think, let's see how the world reacts. Because right now in Android, yeah, a lot of teams and companies are picking this up and making amazing applications. But on the web, it's pretty much Google who is doing material design. And on iOS, the same thing is happening. So I think we need to wait a bit more for the web and iOS, because for different reasons, this is expected to move a bit slower than in Android, because it's a Google library, mostly targeted towards Android. So they move slowly, but I think it will depend very much on the adoption from the developers and designers around the world. I hope so. I'm not a fan of material design on the web. I think it works well, but not a fan. But on mobile, both on Android or iOS, I think it works really good.
Okay, anyone else? We still have time for one question. Or not.
Everybody wants coffee. There's an arm up there.
Okay. Just a second. You'll have the mic in a minute.
You can have it faster.
10 seconds. 5. Really? 6?
Hello? Okay. Just a quick question. You're still in beta, right?
Yes.
But you have the feedback review. What do you say it's the improvement of the overall rating from before you use material design and after?
We are still in beta, but I can talk about other apps which I've been monitoring, if that is interesting to you.
Yeah, yeah.
So I've been monitoring mostly Pocket, which is a pretty known read it later app for Android. I've also checked New York Times a few months ago and how it is now, especially now because it won a Material Design Award by Google. And the ratings have been up. For Pocket, it didn't change much. It's like higher 0.03%. For the New York Times, it rose a bit more. And I think it's because the crowds of Pocket and Material Design are very different. And the users of Pocket are more likely to have already rated. So I guess it kind of makes sense. But as usual, as with all changes, especially UI changes, Material Design, most people love it, some people really hate it. And even during our beta, thousands of people testing our beta, and we have received feedback like, why is this not cramped? Why is there so much white space? Why can I read this properly? Why can't you just like cramp it all up on the top of the screen and let me see 20 things at once? And some people really want that, some people really like that. It's just that Material Design is not about that, and we also don't believe in that kind of organization. So it's been good for ratings, but not that much from what I've seen.
Okay, thanks.
Okay.